So solving algebraically here, when you have your calculator available, what I am looking for with these rational inequalities is just to see you moving everything to the same side of the equation in order to get 0 all by itself, combining into one single fraction, and then identifying where you have zeros and where you have asymptotes. And then you can put it in your calculator and look at those intervals, just like we did on the notes, on the graphing notes that we did on the front. So luckily for us, on this problem, we already have everything set equal to 0. It's very similar to the problems on the front. So here, we have an x-intercept. See, the x-intercept comes from the top, so it's at x equals 3, which is a 0.30. So we're going to need to look at what's going on either side of 3. We also have an asymptote, vertical asymptote, at x equals -1. So the two spots we're looking at, we're going to kind of look at to the either side of -1 and 3. So go ahead and put that in your calculator. Pause if you need to, because I'm going to keep rolling here. I put this in my calculator, and here is my picture. Just verifying that asymptote at -1 and that 0 at 3. So here we want to know where this is greater than 0. So where is this function above 0? Well, so we're not including, we're just doing above. So this whole guy, as we approach -1, that whole branch of the graph is going to be above the x-axis. So that's going to be from -infinity to -1. And since we're talking about an asymptote there and -infinity, we're going to use parentheses with everything. Between our asymptote and 3, we're below the x-axis. So that does not solve our inequality, since our inequality is greater than. At 3, we're going to have an open circle for this one because we don't have an equal to in our problem. At 3, we cross over and then we're above the x-axis. So from 3 to infinity, and we're not going to include either of those. Our set notation for this, x is less than -1, and x is greater than 3. And then slide and order in between. So that was very similar to the problems we did on the front. Now we're going to have a little more work for 6, 7, and 8. For number 6, you can absolutely graph this and just look at where it's greater than 1. I think it's a little more tricky, and I want you to practice getting this all into one fraction. It's going to be much easier when we eventually take your calculator away at the end of the year to do limits of rational functions. It's going to be much easier to get this all into one fraction. So I'm going to subtract 1 over greater than or equal to 0 once we subtract that 1 over. Of course, I need a common denominator. And you can already, hopefully you're already thinking, okay, see where my asymptote is going to be. In my numerator, I need to distribute that -1. So I have x plus 2 minus x. And then that becomes a +4. My x's cancel, so this ends up looking like this. What I'm actually doing is seeing where 6 over x minus 4 is greater than or equal to 0. So what asymptotes and zeros do we have going on here? Well, we don't have an x in our numerator, so we don't have any x-intercepts. Should make sense since our fraction is bottom heavy. We would have a horizontal asymptote at y equals 0. And and this one is not crossing that horizontal asymptote since we don't have a root. So all we need to look at are either side of our vertical asymptote, and our vertical asymptote is at x equals 4, just setting that denominator equal to 0. So if you need to pause, and let's take a look at this in our calculator, go ahead and pause and pull that up. All right, so this is what it looks like in my calculator. Just verifying that beautiful vertical asymptote at positive 4. So here we were solving for where we're greater than or equal to 0. So where is our graph above the x-axis? And since this has that horizontal asymptote at y equals 0, it's a pretty straightforward one. We're going to be above 4, above x equals 4 when our graph is above 0. If you didn't have a calculator, you could absolutely do this problem. You would just pick a number that was less than, if you looked at my notes online, that's what I did. Pick a number that's less than 4, plug it in, see if it's greater than 0 or less than 0. Pick a number that's greater than 4, plug it into 6 over x minus 4 and see if it's bigger than 0 or less than 0. And that just tells you where that curve is living. So our solution here is just going to be a single little interval notation guy from 4 to infinity. And since that's an asymptote, even though we had a greater than or equal to here in our problem, since we're looking at an asymptote there, a vertical asymptote, we need to use that parenthesis and just the x is greater than 4. All right, a little more algebra on this next problem. If you want to just look at the graphs, you absolutely can. That last one, we could have inspected that graph from the very beginning and just kind of draw ourselves a horizontal line at 1. This next one, if you put 1 over x minus 2 in your calculator and then put 2 over 3x minus 9 in your calculator, it looks really nasty. It's pretty gross. So, and it's very hard to tell what each function is doing and where each function is greater than each other. So that's why getting these both onto the same side, turning them into a single rational function is really helpful when we're working on solving these inequalities. Okay, oh, spoiler alert. Sorry about that. So our first step here is to just kind of algebra ourselves out of this difficulty. I'm going to subtract 2 over 3x minus 9 over to the other side. You can absolutely move the 1 over x minus 2. That does not matter. I don't know why I picked this. Just I like my work to be on the left side, I guess. I'm leaving myself room to build in some common denominators here. So my first fraction is going to need the 3x minus 9 over itself. My second fraction is going to need that x minus 2. You could have absolutely factored the 3 out of the 3x minus 9. I'll do that in a minute. But it doesn't affect what you need to do with the common denominator here. So my common denominator is x minus 2 times 3x minus 9. My numerator is going to look like this. 1 times 3x minus 9 is just 3x minus 9. Distribute my 2 through, negative 2x, negative 2 times negative 2 is positive 4. And then I'm going to clean this up. I'm going to clean it up in the numerator and in the denominator. In the numerator, I'm going to do my combining like terms here. 3x minus 2x is just an x. Negative 9 plus 4 is negative 5. In my denominator, I'm just going to switch the order here. I'm going to pull that 3 out of 3x minus 9, make this 3 times x minus 3. So there's my combined rational function. It's a really pretty one. We have nice stuff to look at here. So we do have an x-intercept. Our x-intercept again comes from the top. So our x-intercept is going to be at 5, 0, or x equals 5. This is a bottom-heavy fraction. We have more x's on the bottom than on the top. So we have a horizontal asymptote at y equals 0. Now we are crossing that horizontal asymptote since we have an x-intercept. And then we have vertical asymptotes. At x equals 3 and x equals 2. So the places that we're really going to focus on are going to be our roots and our vertical asymptotes. That's where we're switching from positive to negative or negative to positive, potentially. So let's look at our graph. So put that into your graphing calculator if you have it yet. Pause if you need to. Here is what my graph looks like down here. It is really hard to tell, and so that's why it's really important to see, what is going on here, where we're below and where we're above the x-axis. And your table will help you out with this as well. So we want to look at, let's go left to right. We'll look at our vertical asymptotes first. We have that vertical asymptote, and we're looking at where we're less than 0 here. Where are we below the x-axis? So from negative infinity to 2, we are definitely below the x-axis. We know we don't have any roots there. We don't have any x-intercepts there because there are none in our equation. So from negative infinity to 2, we are below the x-axis. From 2 to 3, we are above the x-axis. There's a little curve there that looks almost like a parabola. From 3 to 5, we're below the x-axis as well. Again, we're just doing a strictly less than. So from 3 to 5, strictly less than, so even though that's a root, we're going to treat it like an open circle. And then on the other side of 5, it's a little hard to know what's going on. So you can use your calculator table. You can use the table in your calculator and just look at what the ordered pair is at 6. Or you can just put 6 into the equation. And here's what that would look like. So if we're wondering what's going on the other side of 5, I'm going to put in 6 because 6 is bigger than 5. And just see what's going on. So 6 minus 5 is 1. Down here I have 3 times 6 minus 3 is 3. 6 minus 2 is 4. 3 times 3 is 9, times 4 is 36. That's a positive number. So there's an ordered pair over here that is 136. That is above the x-axis. And again, you can, if you're like, yikes, that is way too much for me. That's okay. That's in your calculator table. That's just me showing you how you could find that without your calculator. Because eventually we will get there, very late in the year. So from 5 to infinity, we're above the x-axis because we don't have any other x-intercepts. All right, so in set notation, x is less than 2. and x is between 3 and 5. There's our solution. Okay, one more with the algebra. Again, I'm going to start by getting both of my fractions on the same side of the equation. And here we're going to do greater than 0. So where are we above the x-axis? Before we can get there, we need some common denominators. And leave myself an number and define a common denominator here. So my x minus 3 fraction needs x plus 1. My x plus 1 fraction needs x minus 3. And of course, what we do to the denominator, we have to do to the numerator. Now we just need to clean up the numerator. 5x plus 5. Careful with this negative here. Negative 3x. Negative 3 times 3 is 9. 5x minus 3x is 2x. 5x plus 9, or sorry, 5 plus 9 is 14. So where am I looking on my graph? Well, based on my equation, I'm looking at my 0 here, x-intercept. I'm going to expect to see an x-intercept. We do 2x plus 14 equals 0, 2x equals negative 14, x equals negative 7. So we're going to look at negative 7 and on either side of negative 7. We're also going to look on either side of our vertical asymptotes here at negative 1 and positive 3. This is a bottom-heavy function, so our fraction, so we do have a horizontal asymptote at y equals 0 that we are crossing. All right, go ahead and put that in your calculator. You've done all the algebra. If you wanted to write this guy as 2 times x plus 7, you can absolutely do that. All right, so here's the graph we're looking at. We do have those asymptotes happening at negative 1 and at positive 3. And we have an x-intercept. It's hard to see even on this graph. We have this x-intercept at negative 7. So we're looking at where we are above the x-axis. I would much rather do that than look at these two functions together, even if it was a color-coded graph, and see what was going on. So from negative 7 out, it's a little bit hard to see. So again, I would really stress to look at your calculator table or to put a number in for x. If you put in negative 8 for x, you get, here's negative 8. That point is negative 8, negative 2 over 77. And really the only thing we care about there is that is negative 277. Negative 277 is below the x-axis. And we are just looking for above the x-axis and strictly above. We know that we have a 0 at negative 7 that we're not going to include. And our function then switches to going above the x-axis until we get to negative 1. So from negative 7 to negative 1, our function is above the x-axis. From negative 1 to 3, it's very obvious that our function is below the x-axis. And from 3 to infinity, our function is above. If you're thinking, how do we know it's going to stay above? Here's the thing. There are no other x-intercepts. So this graph is not crossing the x-axis anywhere out there. We know that from the algebra. We only identified one x-intercept. So we need to include from 3 to infinity. In interval notation, or sorry, that was an interval notation. This is a set notation. So between -7 and -1, or greater than 3. So there will be a problem like this on the test that if you watch this video, I think you will be able to tackle beautifully. There's some practice that goes with this at the bottom or attached to the notes, so please try that as well. Make sure you get the practice in before you tackle it on the test for your 100%. Awesome.